Let's say you want to send a courier to your friend staying in another city. What do? You give the parcel to the courier company, and after a couple of days, your friend receives the parcel, right? Well, if you look closely, it is not such a simple process. There are a number of steps that are involved. Let us look at these steps. So first, we wrap the parcel in a cloth or put it in a paper bag so that it can travel safe. Then we add the recipient's address and name, and also our name and address to the parcel. Then we go to the courier service office and they give us some stamps to be put on the parcel. Next, someone is assigned to carry the parcel on the train or flight. Once it reaches the destination city, someone picks up the parcel from there and takes it to the courier company. Then again someone is assigned to deliver the parcel. And finally it is delivered to your friend. Just like we saw in this example, the transfer of data from one node to another node has multiple steps involved in it. To give you an idea, the data that we want to send is in the form of text, images, videos, files, etc. But this is not the form in which data actually travels. So these steps will involve converting data into appropriate computer-friendly form, breaking it into data packets, then assigning all the information that we want to attach like IP address and port numbers and a host of other metadata that is required to send a packet safely. And then the actual transfer through physical wires takes place. So all of this goes into the background while we just think we hit a button that says enter and the data is received by someone sitting across the world from us. All this work is not done at once but in a particular order, and there are different layers to take care of each task. These layers make up the TCP/IP model. Now let us look at the TCP/IP model in detail. The TCP/IP model has 4 layers to it, and there are different protocols or rules for carrying on the work of each layer. All these layers deal with different aspects of data transfer. So data always travels from layer 4 to layer 1 at the sender's end and from layer 1 to layer 4 at the receiver's end. Let's look at the layers and their functions in detail. The application layer. This is the 4th layer of the TCP/IP model, and its job is to convert all data into computer-friendly format, since that is the only language that computers understand. So we can say that it encodes, compresses, and encrypts data. Now the application layer also initiates sessions. So what are sessions? Sessions are used to establish a communication between two devices. We can understand this with the help of an example. Let's say I call up my friend. Now, when she picks up the call, I tell her, "Hey, I need to talk to you." She says, "Sure, tell me." So here I have initiated the conversation and my friend has acknowledged the start of this conversation. This is how it works in the world of internet communication also. The session is set up here. When the conversation is over, I say, "Thank you so much, bye." And my friend replies, "Okay, bye." This here denotes the end of the conversation, also called the termination of session. So, we can say that sessions are information signals sent from, let's say, node A to node B. It lets node B know that node A wants to communicate with it. Once node B confirms that it is ready to communicate, the actual communication starts. Similarly, when one of the devices wants to end the communication, it again sends the termination signal to the other device and the other device acknowledges it, thus terminating the session. So, a session involves signaling to set up and manage communication between two devices. Now, we know the job of the application layer. But what constitutes the application layer? Our browser acts as the application layer. This means that the browser not only acts as an interface for the client, but it also converts data to bit streams and also provides session details. Protocols that run at the application layer are HTTP, FTP, and Telnet. The transport layer. This is the 3rd layer of the TCP/IP model. This is where the port numbers are added to the data packet, thus an application-to-application connectivity is formed. The two transport protocols that run at this layer are TCP and UDP. Don't worry if you know nothing about these. We will look at them in a short while. The network layer. This is the 2nd layer in the TCP/IP model. This layer adds the sender's and receiver's IP address on the data packets. Now, we know that an IP address is called a logical address. It has two roles. One, it is the address of a device, like the phone number of a phone. And 2, it provides the logical path that needs to be taken by a data packet to reach the destination device. So we can say that it is the address and also acts as the GPS for the data packets, telling them the right path to take to reach the destination. That means the network layer performs the task of IP addressing, routing, and virtual pathing. Another job of this layer is to add MAC addresses to the packet. A MAC address is the physical address of the hardware of the device. You can see them etched at the back of every device. Now, the protocols running at this layer are DHCP for assigning the IP addresses, ARP for conversion between IP and MAC addresses, ICMP for debugging network stability and deliverability. We will learn more about these protocols as and when we encounter them in the training. For now, you can read more about them and increase your knowledge bank. The physical or network access layer. This is the first layer of the TCP/IP model. This is where the binary signals are converted to electrical signals so that they can be transported over the physical cables and optic fibers to the destination device. This layer comprises of the hardware which is used for data transfer, and it also checks itself for errors. It also controls the flow of data. An example of this is your Wi-Fi adapter. The common protocols that run at this layer are Ethernet for LAN cable, 802.11 for wireless connections like Wi-Fi, Bluetooth, etc., and DSL for telephone cables. Once the signals are sent over to the receiving device, they are again processed at all the layers of the TCP/IP model, but this time the order of the layers is reversed. So whatever information was attached by the layers at the sender's end is now read by the same layers at the receiver's end. First, the signals are converted into binary code at the physical layer. Next, the network layer reads the IP address and the MAC address, identifies the device, and removes this information from the data packet. After this, the data packet is passed on to the transport layer. Here, the port numbers are read and the data packet is directed towards the right application. The port numbers are removed from the data packet before passing it to the next layer. Next, the data packet goes to the application layer. Here, the session information is read and a session is thus established. Also, data is converted into its original form, which is user-friendly. This data is then presented before the user. So, that was all about the layers of TCP/IP model. Click next whenever